a bunch of radical stuff up to this point. And we're going to look as our last kind of last types of problems we're going to do in this unit. We're going to look at this type of equation, which is a little bit different than the ones we were looking at last time. If you kind of compare this equation to one of the ones that we did from homework last time where you had radicals in them, do you see the difference, right? We have radical equations with square roots or cube roots even if we needed to. And this one doesn't have a radical, but it has a fractional exponent. We call that a rational exponent, okay? So if it has a rational exponent up there, we're going to do the same. We're going to treat it as though it was a radical, and we're going to isolate the radical term. Now, it doesn't have the radical in it. It's written as a fractional exponent, but it's the same kind of thing. What is currently with it on the same side of the equal sign?
X plus 3 and 2.
Well, x plus 3 is in parentheses, so that's the term I want to get by itself, but what else is with it? The 2. So I need to get rid of the 2. I need to isolate the parentheses. Well, it currently is being multiplied, so I don't want to multiply. I want to undo that. So what am I going to do instead? I'm going to divide. The opposite of multiply is divide. So I'm literally going to divide both sides of my equal sign by 2. And when I do that, on the left-hand side, they cancel. And on the right-hand side, we have a what? A 4. Good. Okay. At this point, is the radical or the what's in parentheses by itself? Sure it is. There's nothing else being added to it or multiplied by it. I just have parentheses with an exponent, correct? It's the same thing as this. Remember? Do you agree with that? Remember, that's the radical part. This is written as a rational. Either way. So once we've gotten it by itself, well, remember before what we would do is either square both sides or cube both sides or whatever. When you have a fractional exponent, you're going to raise each side to a power, but this time it's going to be the reciprocal power. What does reciprocal mean? Do you remember? It's not the inverse. It's when you switch the numerator and denominator. People tend to call that the inverse. It's not the inverse. It's something else. Maybe the multiplicative inverse. Maybe that's what you were referring to. Yes, baby. Go ahead. Use the one behind my desk because this one doesn't work real well. So this would be 3 over 2, and we're going to say 4 to the 3 over 2 power. Okay? We're raising both sides to the reciprocal power. Make sure you're writing this down, honey. Okay? Now, on the left-hand side, do you remember when I have a power to a power, what do I do with these two terms? Well, they do reduce to 1, but how did you get that? What did you do with those numbers?
Are we writing any of this down?
I would, yeah. I actually multiply. What is 2/3 times 3/2? No, it's 6 over 6, which is 1. Okay? They are multiplicative inverses. They multiply to be 1. So I have just x plus 3 equals, well, what in the world is 4 to the 3/2? You write the problem, and then you just write the steps that we're going through. What is 4 to the 3/2 power? It doesn't give you a, I'm using the wrong calculator, sorry, baby. It doesn't, you can plug it into your calculator if you wanted to. So you would say, oops, sorry, 4 raised to the, and then we're going to put it in a fraction. So 3 over 2 power, and you're going to get 8. Okay? So 4 to the 3/2 power is 8. Did you see how I plugged it into my calculator? Yeah, go ahead. Tim, you're like 5 minutes behind us, honey. Come on. Come on, let's go.
Wait, so where do we plug that 1 in?
I did what? What did I do? So I put what in the wrong thing? I'm going to get to the absolute value part in a minute, but 4 to the 3 over 2 is 8. That's what I typed into my calculator. It's this to the 1 power. Anything to the 1 power is just itself. Now, here's the part we kind of talked a little bit about before, and I haven't been super good about, I haven't been super good about making you do the absolute value, so that's kind of my fault. But let's revisit that. And when do I use the absolute value and when don't I?
When you have the negative.
Since the numerator is even, okay, we have to use the absolute values, okay? The index would be even, not the numerator, the denominator. It's this right here is even, since the index is even. When the these canceled and became 1. So
you just rewrite it.
I just rewrote it right over here. But because your index is even, we're going to use the absolute value. In other words, the denominator of what you're raising each side to. These numbers here are both even. You're going to use absolute value. Okay? So that's where this comes from. Now, I'm trying to do a check mark. When the index is even. 4 to the 3 over 2 is 8. Look at the calculator on the board behind April. Okay? Now, if you remember back in the first week of school, when we did absolute value equations, don't you have 2 possible answers? We have the equation that you think it is, and then everything inside the absolute value is different. Do you remember that? When you have an absolute value equation, you have 2 possibilities for an answer. So we go from here to these 2 possibilities. Okay? Whatever's inside the absolute value is what you think it is, or the signs are opposite of what you think they are. So then we subtract 3 from both sides. So one of my possible answers is 5. We go over here, we're going to add 3. Divide by -1. The other possible answer is -11. So x equals 5 or x equals -11. Now we want to see whether or not either of those are extraneous solutions. So a quick way to check this, because it has an equal sign in it, is to plug the problem into the calculator. Don't you agree? I think we should. So let's plug the left-hand side as y1 and the right-hand side as y2. So let's go ahead and plug it in and see what you get. Do I get both of those to be an answer?
Yeah.
I don't know if we do or not. We'll have to see. Now, the problem with my standard window is that -11 is not going to show up, is it? So let's see if 5 does first. Let's graph it. It's kind of a strange looking graph. All right. And someone wants to turn their phone off, that'd be great. It does appear that it crosses in both spots. Let's find the one over to the right first. If I calculate the intersection, it's going to give me 5 as one of the answers. I want to check on the left. How do I make the window go further to the left? I'm going to go to Window, and I'm going to make my X-min go to like -15, just to make it more to the left so I can see it. And then we should be able to see that it crosses there too. Yes? Because when I have an absolute value equation, the first equation is like what you want. The second equation is what's inside the absolute values have the opposite signs. So it does cross at -11 too, doesn't it? So both of these are in fact the answer. And honestly, you could have done that right from the beginning, couldn't you have? Right? Without even doing any of the work. I'm not encouraging that. I'm just saying you can check your answers. Y equals 5 is the horizontal line. It's actually 8, sorry. Wasn't it 8? Oh, where's the 5? The 5 is where they intersect over there on the right. That's what I did. So watch. I calculate the intersection. I'm going to try to get closer. I think this one over here. So if I just hit enter 3 times, I got 5. If I go to calculate the intersection, and I want to go on the other side, I'm going to move this to the other, closer to the other point, and I'll get -11. It takes a second to get there. Let me just move it quickly. We're just moving it to the other side. All right, so it's somewhere around here. We'll hit enter 3 times, and we should get negative 11. Okay.
When you, like, so you just hit from the original problem?
The original problem, the left-hand side and the right-hand side. It actually works for any equation at all.
So we put that in the calculator?
The left-hand side and the right-hand side, yes. Both, yeah, because it crosses in 2 places. So both, there's no extraneous. They both work. You may use your calculator to check your answers. Remember that on Thursday's radical portion, it is multiple choice, but if you want extra credit, which you all really need at this point because your first quizzes were so bad, then you need to show me the algebra.
On the mic?
On the mic. They were bad, but you're going to get chances to fix it.
Were you your only algebra 2 class?
No.
Did your other algebra 2 class do like that?
They did not do as well either. All right, let's do one more.
I don't understand it.
Let's do one more.
Maybe I put that in the calculator to 2 to 3.
You raise it to a power and you put the fraction in. Let's try this one. I want you to first try it algebraically, and then I want you to use the calculator to check your answer. So I'm going to pause the recording. I want you guys to try first. When you graph this, you might want to start with the graph so you know how many answers you're supposed to get. That's a good idea. So let me pull up my calculator here and let's plug it in so we know what this is supposed to look like, or at least how many solutions we should have. When I go to my y equals, it's 3 parentheses x plus 1 raised to the, I'm going to put it as a fraction, 2 over 3 power. So everything on the left-hand side, we want it to equal 12. If you view this from a standard window, you won't see anything because 12 is too tall. 12 is too tall. So you're going to have to make it taller so you can see. So we'll need to go to our window. Hang on. We need to go to our window. Really? It doesn't like that. Let's try again. Window, there we go, and go to our y max, and at least go up to, higher than 12, like 15, 20, something like that. I'll just go ahead and go to 20. And then if we graph it, we should in fact see a couple of different places that it crosses. So it does cross in 2, just like the one before it, and we want to be able to find the 2 answers. If we calculate the intersection, we want to move our little flasher guide closer to where we think the intersection is, and we'll press enter 3 times. So 7 should have been one of the answers. The other answer, okay, that's fine. What, baby? Okay, so if you're in your y equals, how do I get that fractional exponent? Go to alpha y equals, and it will say n/d. That means numerator, denominator. So I did get negative 9 and 7. Let's make sure we know algebraically how to do it in case we're stuck. So I'm going to divide by 3 first. I'm going to raise each side because now I have it isolated to the 3 over 2 power. And I get x plus 1, the absolute value, is equal to 8. Remember that when you raise it to the index being even, you should be absolute valuing. So the 2 solutions, x plus 1 equals 8, or negative x minus 1 equals 8. So x is 7. We got that on the calculator.
My question is, I would have liked if it was a negative index.
Well, that's a really good question. I don't think we would do that in this case. But a negative index or a negative exponent?
What if it was 2 over 3?
Oh, not negative then. You mean like if the denominator was odd, then you wouldn't worry about absolute value. Okay? All right. So I'd like to start with the quizzes. How much time do we have here? We have 30 minutes. So I would like for, if you haven't taken the quiz, I know that Alex is in that situation, Bradford's in that situation, I believe. Jessica's in that situation. Let's see who else. April, did you take your quiz yesterday afternoon? So you're going to take it right now. Trent did, Moody did, Shamar did. Daniel, you'll need to take it today. Alexis still isn't here. Christian and Gabby, did you take yours yesterday, right? Gabby, you took yours yesterday, right? Okay. While you're working on your quiz corrections, I'm coming by and giving you a copy of the second quarter review. The second quarter review, you're going to have a quarter test. The only portion you are taking next time is the radical portion, and it is multiple choice questions. So the first two sections of this review are in fact stuff from complex numbers, and what was the other portion that we did? Complex numbers, and the middle portion was polynomials. So there's three sections to this. Please only complete the last section, so last few pages on radical and rational exponents. And that will be, in fact, your homework. And then you're going to have the test portion of this next class. Okay? So you have your homework to do. Your quiz corrections are going to, in fact, be due before you leave today. You have approximately 20 minutes to finish those quiz corrections.
Or do you want us to do